How are you? I got the
Hello, can you guys hear me? Test, test. Test, 1, 2, 3. Can you guys hear me? Those online. Can I get like a thumbs up or something? Yeah. Okay, cool. Can we go back to the first slide? Okay. So, let me stand here. So you can see. Okay, so hi guys, good morning everyone. Welcome to Malaysia Machine Learning Study Jam 2022. I'm Gregory, I'll be your MC for today. I'm also one of the organizing committees for this study jam. So for those physically joining us, just some safety precautions. The emergency exit is on your left, and basically you can take the emergency stairs to go down. If anything happens, but we hope it doesn't happen. All right. Guys can hear me, right? Okay. Next slide. Okay, so just some ground rules before we start. Please mute your mics and devices during the Zoom session. For those that are joining us physically, please mute your devices, and for those online, please mute your mic. Yeah. And then feel free to post your questions to the Slido. We have this QR code on the right with the bit.ly link. So if you have any questions throughout the session, feel free to post them there. I'll leave this up for a few minutes first. And most importantly, I hope you guys enjoy the session and then have fun learning. All right, I'll leave this up for like 1 or 2 more minutes for people to scan the QR code. All good? All right, next slide. Okay, so for today, before we start, we'll have opening remarks from Miss Janise. So Miss Janise is a World Region Lead Developer Relations Ecosystem in Southeast Asia. For those that are familiar in the Google ecosystem for GDG or the GDSE, the Student Club, then we'll know Miss Janise. So without further ado, I will pass the floor to Miss Janise to have her opening remarks.
Thank you so much, Gregory, and thank you to the 𝐷𝐸 Tech Club, 𝐷𝐸 University Research Cluster, and the TensorFlow Deep Learning Malaysia User Group for inviting me to join you in kicking off the Malaysia Machine Learning Study Jam. I hope you're as excited as I am to do this hybrid event together. I wish I was there with you in person, but I know some of you are actually dialing in. I see about nearly 200 people on the chat, and I know there are also a lot of you who are in person in 𝐷𝐸. Thank you so much for joining us bright and early on a Saturday morning. I can feel the passion that you have for learning coming together on a Saturday morning. So Dr. Pooh has been a strong, passionate advocate of machine learning in our developer community. Thank you, Dr. Pooh, and of course the Sunway team for leading the charge and putting together this month-long machine learning study gem to help developers in this room, developers like you, upskill themselves and learn new technologies. We know that machine learning engineering job roles are among one of the highest paying jobs in the world. And we hope that this opportunity to learn among like-minded peers in a safe and supportive environment will help you to have this opportunity to learn a new technology, ask questions in a safe place, get connected with like-minded peers, and of course, consult with all the experts who have dedicated their time to mentor, support, speak at this event. I'm really excited to see everybody come together today. And I look forward to actually seeing what you'll be learning and the end, what you'll be able to put forth these new skills to roll out in new projects that will be good for the community, good for the world, because we know that technology is what's going to help improve and change the world around us. And I'm very happy that we're here together today to kick this off. Thank you again, Gregory and Dr. Pooh, for having me, and I'm really looking forward to see the content that we have today.
All right. Let me 1 second. Okay. So thanks, Ms. Janise, for your opening remarks. Now we'll go into now we're going to like a quick 5 minutes break before we have our workshop by Dr. Pooh. So next slide, please. Yeah, we have a quick 5 minutes break. So if you guys need to like refresh yourself, go to the toilet, or before we have the workshop, then please feel free to do so. Yeah. All right. And I'll have the music play in the background. All right. Okay, great. Okay, next slide. Okay, so now we're getting to our introduction to machine learning talk/demo. This session will be conducted by Dr. Pu, a Google developer expert of machine learning and also a lead data scientist. He's also a founder of the TensorFlow and Deep Learning Malaysia user group, and he's also one of the organizing committees of this study jam. So without further ado, I'll pass the floor to Dr. Pu.
Hi, good morning, everyone. So nice to see everyone is here this morning. So before I talk about the introduction to machine learning, I think it's my duty also to explain to you what is study jam. Because a lot of people ask me what study jam. And then I cannot attend if I don't attend the class, what will happen to my certificate? I think a lot of people confused. I think better I explain what is study jam. So let me share the screen. Okay, the first thing we created a website for you with a very simple URL, Malaysia ML studygam.com. Okay, just go to Malaysia ML studygam.com. Okay, so if you have any things that you want to check, just go to Malaysia ML studygam.com. Okay, if you are using somewhere Wi-Fi, too bad the website is blocked. That's why I'm sharing using my own computer and using my hotspot. If you are at home, I don't know why somewhere blocked it. Maybe somewhere not happy with it. But if you are using at home, if you are accessing this online Zoom now, you can see this website. Okay, Malaysia ML studygam.com. Okay, what I want to show you is first thing, go to the resources. Okay, go to the resources. So when you go to the resources, you can see all the links there. Okay, the first most important link is kaggle.com/learn. Okay, so what is study jam? Study jam means you can actually learn on your own anytime actually. 𝐾𝐨.com/learn has been around for some time already. Okay, but there's a lot of studies show when you take courses online, because you're alone, usually by week 3 or week 4, you'll be demotivated and you cannot complete the course. That's normal, isn't it? I think we have probably experienced that many times. We are very motivated to sign up for a course. By the time we go to module 2, module 3, we didn't complete. And you go back to some of the courses even that you bought from Udemy something for $9, you probably see a lot of courses not completed, probably 50% or 60%. Okay, so why we have study jam? So study jam is come to actually for you to provide support to you. You can actually learn anytime, but we provide you a session where we have taught by data practitioner. We also created a discussion channel. So we want you to support you. Within this 4-week period, we want you to complete the course. That is the purpose of study jam. Okay? So every week during the event, don't expect we give you lecture. Okay? It's not lecture. Okay? It's a support. So what we try to do is we get people who are professional to give you something that knowledge beyond the machine learning. Probably somebody talk about computer vision, probably somebody talk about Google Cloud, something like that. Okay, so we hope with this community, we hope you can complete within these 4 weeks, complete these 𝐾𝐨 courses and get a certificate. Okay, then you can show off the certificate to the community that within these 4 weeks you completed it. Okay, so there's no lecture, there's no training provided. Okay, but we are coming together as a community. So is it clearer now what is the study jam? Okay, so a lot of people ask me, oh, what happens if I cannot attend one of the sessions? Do I not get any certificate? No, you can do your certificate anytime, but try to make it a commitment to finish the whole session in 4 weeks, so you get a certificate. This is like a community support, isn't it? A lot of time we just fall off because we don't have a motivation, we cannot complete the course. Okay, so by building the community, we want to help you. We will create, okay, because of that, we created a Discord discussion channel. Okay, there's a link here, join this channel. Okay, if you go to the channel now, we have around 100 people there. So we also have a dedicated tutor there. So if you have any questions, if you have any doubt, or some of the assignment you cannot finish, because in the 𝐾𝐨.learn, 𝐾𝐨.com/learn, let me share the website. So when you go to 𝐾𝐨.com/learn, you can see these are the courses. So every single time when you finish one course, you get a certificate. Okay? The certificate is online. Okay? So every time, okay, there will be some exercises that you might ever start with. So we provided this Discord channel, so you can actually go in and discuss among yourself, even share your answers. Probably you have other ways, to solve a certain programming question. Okay, and then we have a dedicated tutor there who help you. Okay, so is it clearer now? Okay, of course, machine learning or data science or AI itself has many resources online. This is one of the resources that you can access. There's Coursera, there's EDX, there's if you want to pay, you can go to Udemy. Okay, there's Udacity. There's so many of them. Okay, but 𝐾𝐨, the good thing is, okay, you can also do all your coding, okay, using the 𝐾𝐨 notebook. Later, during demo, I will show you. Okay. Okay. And I also created a GitHub page. So in the GitHub page, okay, the screen not very clear. Okay. So on the GitHub page, you can see, for example, today, week 1. Okay. I also created the slide is here. Later, the slide is here. And also the notebook. Okay, that we are going to do demo and some exercise. Okay. So we might not be able to complete the exercise today because, come on, talk about pandas and machine learning, only 2 or 3 hour sessions, it is possible. People study for 3 years for AI. Okay, what I can do, that's why I said I want to do a demo. I want to show you what is a basic workflow for machine learning. Okay, then you can have a good understanding, then you can actually try it. Okay. So the notebook inside the GitHub, okay, you can open up in Google Colab. So for example, let me open one of these. Okay, it's shown here, open in Colab. Okay, so if you click on that, okay, you open up in Google Colab, and then I say, please go and save a copy. You can run this code in your browser. Okay, and then this code will be saved in the Google Docs. Okay, of course, you can do the same thing in Kaggle notebook also. I will show you that also. Okay. Is there any questions so far? Is it clearer what is ML study jam? Okay. Is any questions? Slido? No questions. Okay, good. Okay, if there is no questions, I will go back to my other machine because I cannot access the Malaysia MLstudyjam.com just now. Okay, let me share the screen here. Okay, so to the session today, I'm planning to give you a very high level overview. But before that, I want to do, okay, before that, I just want to do a short survey. Can you go to menti.com? Can you go to menti.com and type in 97573380? I just want to have a gauge. What's your background? Okay, go to menti.com, type in the code 97573380. So I just want to know what is the basic background of the participant. Okay, seems like the race, huh? Okay, very evenly split. Okay, seems like the, okay, I wanted to say the no one, okay, but still evenly split. Okay, so basically, half. Okay, some people have totally no experience in programming and machine learning. some half of you have some experience in programming and machine learning. Okay, so I will try to bring down the level of the talk today to give you an overview. Okay, of course, when we talk about machine learning, AI, data science, there's a lot of algorithms, there's a lot of theoretical behind it. Okay, I cannot go through all that. Okay, then you will become a lecturer. But I will give you an overview. Hopefully, after today, you have a very overview of basic understanding what's machine learning. And then when people ask you what's machine learning, you say, yes, I know. I attended 2-hour sessions by a talk by this guy, so I know what you. Okay. Next question I want to ask. Okay. I want to ask, how many of you have started learning with 𝐏𝐨𝐨.com and have completed how many modules? Okay. Majority 100 overview I will say. Okay. Oh my God. Okay, at least there's a good sign that 19 people have at least completed one module, which is the introduction to programming. I think hopefully. Okay. So those people just now who replied that I have no programming experience and I have no machine learning experience, start with the introduction to programming, because then they will teach you about introduction to Python. Okay. Usually I try that. Okay. Even though I know programming. It's not so difficult, and it's a very easy to follow, and the answer is just there. It's just at the comment you can get the answer. But of course, don't always look at the answer first and try. Okay. So by today, hopefully, I see the 139 people haven't started yet. Hopefully, after today, we should get started. Okay, get ourselves motivated and start our journey on this machine learning and learn from the 𝐏𝐨𝐴. Okay. Okay, so like I said today, based on the short survey just now, majority people have not much knowledge about machine learning. Hopefully, after today, we are motivated to start learning about programming and also to start learning about machine learning. Okay, so my name is 𝐴𝐴. Okay, I am the GDE, Google Developer Expert in Machine Learning. Okay, I'm not a Google staff, but basically what we do is we actually help to manage and organize a lot of activities, community events. As for my case, it's mainly related to machine learning. Okay, so I'm a lead data scientist. I work in 𝐵AG. You can actually connect to me in the Twitter. That's my handler. Okay, and then I founded 2 communities in Malaysia. About 7-8 years ago, I founded the Malaysia user group. So if you have heard about data science, there are 2 programming language people commonly use, Python and R. Okay, so I have the I founded the Malaysia user group. Then I also founded the TensorFlow and Deep Learning Malaysia group. Okay, so the TensorFlow Deep Learning Malaysia group mainly we actually have all the activities via our Facebook group page. You can actually see the link in our Malaysia ML-study.com. Okay, so in there we have around 8,000 people. Okay, so if you are keen to participate in the community where we organize events, so every month usually I have a webinar also in the community. So for example, next week there's a webinar where we're going to have a person from Singapore. He's going to talk about what is TinyML. Okay, so please join the Facebook group. And we have a lot of community events inside that. Okay. And if you're interested to look at the slide, the Google slide, you can look at this link, or the Google slide in the PDF is also available in the GitHub. Okay. Okay. So before we jump into my introduction to machine learning, A lot of people will tell you that, oh, we have a term called AI, then we have a term called deep learning, then we have a term called machine learning. So what's the difference? Okay. So if you look at this diagram, Venn diagram here, so AI is basically the whole bigger group, bigger set. Okay. So what's AI? So the word AI means artificial intelligence. Okay? Artificial. Okay. That means you try to train a computer to do something similar to human intelligence, but artificial. So mimicking what human can do. Okay? So what human can do very good. Human can actually recognize objects. Okay? Human can actually understand speech. Okay? Human can actually, so we have audio, we have video, okay? We have text, we have image. So now AI has to apply all these three domains. Okay? Image, video, and audio. So that's why your phone now, like a Siri, okay, or Google Assistant, can understand your speech very well. Okay. Now, if you are lazy, you can just use your voice to control your phone, because the AI has come to a stage to recognize speech very well. Okay. AI also able to recognize image very well. Okay. Now, your phone, you can actually search your gallery photo by just typing a text. That means your phone itself has already the model built-in, can actually find pictures in your phone without installing anything. Okay, and video. Okay, now we're talking about self-driving car. Okay, that means the car can understand the surrounding object very well. So there's AI. Okay, then under AI there's a subset. The subset of AI is machine learning. So what is machine learning? Okay. Machine learning is basically all the techniques, okay, that you can build to achieve what AI can do. Okay, that's machine learning. And then there's a deep learning. Deep learning is another method in machine learning, okay, where you use something what we call neural network. So what is neural network? So neural network, if you know the word neural, it's something related to your brain, isn't it? Okay. So deep learning is a method, okay, where we actually try to build a model similar to how our brain works. That's neural network. So basically today, okay, we are going to start jumping in, learn about all the model in machine learning. Okay. Of course, some people say, machine learning is not happening. I want to learn deep learning. I want to do all the most happening stuff. I want to train my car to drive by itself. Okay, I just want to go straight to deep learning. You can, but if you don't understand the fundamental, the deep learning will not come. Just like I want to know deep learning, but I don't know programming. How I can do? Okay. You said then I can use a lot of tools. Yes, you can use a lot of tools, but tools cannot be customized. Okay, tools are already made. So if you want to customize, you still need to know the fundamental programming. Then learn about machine learning. Then go to deep learning. Okay. So what is machine learning? Okay. So the word machine learning, that means how machine learn. How you want to train the machine to learn. How? Okay. Okay. Human. Let's look at human. How do we learn? How do we learn? From young until now, how do we learn? Okay. So, for example, let's say a small kid, a boy, or a toddler, touch something hot, then he gets burned, painful. Okay. So then in the future, the boy will not touch the surface again because it's hot. Okay. So human learn from experience. Okay. Based on many experience, we learn. But some human never learn. Okay. Always repeat the same mistake. Okay. That's why we have some problem with human also. Don't expect machine to be perfect. Yeah? Okay. Then from there, we build apps. Okay. Our phone, a lot of apps, a lot of software. How do we tell a software, a program to do something? How? You need to code in it. You need to program it. Okay. So you need to do the programming, follow instructions. Okay. The app, the program will not do anything if the instruction not given. Okay. Then what is machine learning? Okay, where the machine learns from, how to train the machine. What is the essential? What's the essential ingredient to learn the machine to learn? Learn from what? Okay, you must have data. Okay, no data cannot do machine learning. Just like I want to train a machine to recognize certain object image. Okay, let's say an image of an apple. Okay, the computer learns that this is an image of apple. How many millions of images to feed to the computer? Then the computer can recognize this is an apple. Okay, for a lot of data. Just for one apple, because apple can be green, can be red. Okay, you can look at it from the top, from the bottom, side view, what view, every single angle the computer must be able to see. Human is quite simple here. You can show a cartoon or drawing image of apple, you still can recognize that apple. Okay, humans are much more better in learning in that sense. So for machine learning, must have data. Okay. So what's the difference between machine learning and programming? Can a programmer, let's say I'm a programmer, I know programming. Can a programming build a machine learning model? Okay. So what's the typical traditional programming? You have some data, you ask your programmer to program, to write all the code. Okay, yes, no, okay, all the code. Then only you can get the output. Okay. If the code not programmed, then you will not get output. Okay, but what's machine learning? Okay, so what's the disadvantage of the traditional programming? If the code is not coded, you won't get output. Okay, but for machine learning, you do not need to define all the code. For example, let's say I want to train the computer, the machine to recognize the object of a fruit apple. I will fit a lot of images of apple and label this is a picture of apple. Okay, with the label. Then my computer, after many rounds, you recognize that this image is an apple. They give you you write the code. They understand it. Okay, so that's the difference between a programming and a data scientist or AI scientist. Okay, a lot of times in the real world, a lot of people they are very good at programming. Okay, but their mentality is I want to code everything. Okay, that's not the way. Okay, you want to help to label the data, feed into the machine, and let the machine use the model to learn. So machine learning is an AI where the computer can learn without you explicitly programming it, coding it. Okay? So, like I said, what's the main ingredient of machine learning? Must have label data. Okay? You say, oh, I have a lot of data of my, for example, let's say in the factory. I have a lot of data of the defect product. So I want to use all these images to tell to the machine to learn that this is a defect product. And this is not a defect product. Okay? You have a lot of images. But you need to ask someone to label it. Okay? If the images is not labeled, then the machine will not differentiate what is the defect and what's not defect. Okay? So this is the biggest problem here. Where to get all the pictures to be labeled? Okay? How? For example, now you have an online car system like 𝐏𝐨𝐶 or 𝐼𝐴 or the other things. Okay? So what they want to do is, okay, they actually want to do is, let's say a seller, they want to sell a car, second car. They can upload all pictures. But upload the pictures, then the system is able to detect this is car, for example, Toyota Corolla, what year, what model, auto label, because even the car there's many models, different versions. Okay, so the system is able to auto label. Then when the buyer wants to find certain model, you can actually find easily. Okay, but to train that, you need to have a lot of data of different cars, different model, different year, make, different color, different version, whatever. So labeling data is one of them. Okay? So there are a lot of companies out there that actually help to label data. Okay? Even like this self-driving car. Also, there are people who do labeling. Have you heard of a company called Superhand? 𝐶𝐴HAND. It's a Malaysian company. So what they do is they help companies label data. Okay. So label data is very important. Once you label data, the machine learning algorithm will use the data to train. Then in the future, when I get the unseen data, I will able to, based on the model that I've learned, I'm able to do a prediction. Okay, so look at this, quite simple. So what's the main takeaway? The first takeaway is I must have label data. Second takeaway is if I train all the model already, my machine already trained, then given the data, I should be able to do prediction. But let's say I want to train a model to recognize fruits. So you have durian, you have mango, watermelon. So you train already. Then let's say I have a data, a photo of a fruit never trained before. Do you think my model will be able to predict that fruit? Do you think the model will be able to predict the fruit if I train a model with all the fruit but not the fruit that you are going to show? Do you think the model is able to predict? No. Okay, it's not that smart. You will never able to predict. Okay? So if you have a model already trained for certain data, if you suddenly show an image never trained before, of course you never able to. Okay, machines like that. That's why it's called artificial intelligence, AI. It's not real intelligence like human. Okay. Okay. So machine learning has three approaches. Okay. Supervised learning, unsupervised learning, and reinforcement learning. Okay. Supervised learning means what? You have label data. Like I said just now, you have label data. That's called supervised learning. But sometimes you have data not labeled. Okay. That is called unsupervised learning. Okay. For example, what's unlabeled? Okay. Let's say I have a Shopee data. Transaction. Who bought what? Is there any label? What do you think is the label? You have all the transaction data. There's no label. Okay. What can you do? Maybe you can ask the machine learning to see what is the behavior pattern. Then certain people have certain behavior. For example, certain people buy things at 11 o'clock morning. Okay, let's say you work in Shopee. Who are the people who buy things at 11 o'clock morning? Don't tell me you are. Who are the people you think will buy things at 11 o'clock in the morning? Think like a data scientist. Who? Imagine who are the people that will buy something at 11 o'clock in the morning? Anyone? Retired people. Okay, why 11 o'clock morning? Because they haven't wake up at 10 o'clock. Anyone? You all don't know whether. Come on, think. What is the most probable people that will buy things at 11 o'clock morning? Yes, housewife. Why? How do you know? You know housewife very well, huh? It's true. It's housewife because morning they probably have sent the kids to the school already. Then they come back. Probably they are already prepared lunch. Then they are free time. They buy things at 11 o'clock morning. Okay. So those unlabeled data, you can actually do some grouping. And you find that, oh, these people all buy things at a certain time, or these people buy certain product at a certain time. Okay, then you will probably say, oh, no, why these people have this certain similar behavior? Then you group them together. Okay, so that's called unsupervised. Okay, then another one called reinforcement. Reinforcement means based on feedback. Okay, for example, when we are kids, when we do something naughty, our parents will teach us, then we will not do it again. But we do something good, our parents will reward us, then we do again. So in computer, you can apply the same concept. But, okay, for reinforcement learning, you must define what is the feedback, you must define what is the reward. Okay. Let me go through one by one. Okay. So for machine learning, this is a problem lah. Classification, classify. Like just now I showed you about identify fruits there, or identify defect or non-defect product. Those are called classification. Okay. Then we have something like this, regression. Okay. For example, determine the price of a house. Okay. Determine the price of a rice or commodity. Okay. As time goes on, the price might change. Or determine the price of a share, something like that. So these are called regression. Okay. Then there's what we call clustering. Clustering means it's unsupervised learning. There's no label data. We try to group them together, cluster them together. Okay. Then of course the other thing that you can do is detect anomaly. Okay. When anomaly will happen. For example, what? For example, suddenly there's a spike in the network. Okay, there's an anomaly. Spike in network is something people always detect. Why? Because when you spike network, probably you're having DDoS. Certain people are hacking your system. Increased activity. Okay, people are very particular about that. Or, for example, sales. Okay, 11:11, there will be spike in the network because a lot of people buying at the same time. Then you need to know why people are buying at the same time. Okay, so a lot of things need to do. Okay. So, what's the difference between supervised learning and unsupervised learning? The two main difference. Supervised learning has label data. Okay, label. Okay, must have a class or value. Okay, unsupervised, no label. Okay, so what's the goal of supervised learning? The goal is to predict a class or predict a label. This is what we call classification. Okay, maybe this is a apple, or maybe this is defect or non-defect. So what's the goal of unsupervised? Determine a group, cluster. Okay. So what's the output? Okay, the output is the knowledge is you need to somebody to label for you. Expert. What's the output? There's no label output because you don't know what you're going to get. Okay. So in supervised learning, what you can do, commonly you can do regression classification. For unsupervised, you can do clustering. Okay. Okay, let's start with the first one, regression. Okay. So what is regression? Okay, regression means you just use a statistical process to estimate the relationship between the variables. Okay. I'm sure when we studied math last time for 5, for 4, we learned this. Y equal to mx plus c. That is the most basic machine learning that you learned in your school last time. And it's still one of the most important machine learning models that you will know. Okay. So based on a law of dots, I want to draw a line that can best represent this dot. So that's regression. Okay. So what kind of data that you get? For example, share market. For example, Bitcoin price. For example, market property price. So based on that, you have a lot of data points. You want to build a model or a formula to best represent this dot. Okay. So for example, here, your data. Okay. So let's say you want to predict a house price. Okay. So your data, room size, number of rooms, number of size of the house, and the price. So where's the label here? What's the label here? The label is your house price. Because based on this room and this size, what's the price? Okay. So a good thing is, the first thing is when you look at data, ask yourself, do I have a label data or non-label data? If you have a label data, then I need to do two things: classification or regression. Okay. So do you think this is regression? This is classification? Classification means you label one class or no class, other class. So in regression, the value is continuous. Okay. If you look at the label, it's continuous, then this is regression. Okay. So whenever you look at data, first thing, see whether you have a label or no label data. First thing. Okay. Then look at the label, continuous or discrete. Then what you can do? You can plot. Okay. This is the price, and this is the, I choose one variable, the size of the house. You plot it. Then what you want to do? You want to find a formula. What's the relationship between X and Y? What's my X? The house, the size. What's my Y? The price. Find a model. Because, but of course, I simplify this. Just now we have two variables here. Just now we have room and size. I just take one now because we can plot room size and also the Y, which is the price. But if I plot, then it's a very complicated graph. Okay, so what do? We want to find the relationship between the price and the price. Okay? Then look at here. If we size 800, I get a price here about 400,000. Okay? If I have a size here about 2,000, I have a price here about 1.2 million. Then what happens if I have a house here around 1,007? What's the price? Okay, what's the price? But if I like to look at here, if I draw or here, there's no point. How do I know what's the price? Then I need to solve this formula. Then if I plug in the house size, I can able to find the price. Okay? So I will draw a line. Let's say I draw a first line. Is this a good line? Okay. How I know whether this is a good line or bad line? How far is my line from the dot? The error, the gap. Okay. So what I do? I measure the error. Okay. So what is my point? The objective here? Find a line where I sum up all the error is a minimum error. Okay. So your machine learning model will, what you do? You draw many lines, and calculate all the error, and then you give you the output of the line, which is the least error. You will not see this. You do it by yourself. Okay. Of course, this is very simple. It's not so simple. But let's say you have many variables. Then it will be very complicated. Okay. So I draw this line and sum out all the error. Is this a good line? I do not know. I'll draw another line. Okay. Then I'll sum out all the errors. Okay. So what your machine learning model will do, you draw many lines, and you move the line until you find the least error. Okay. So let's say whenever I draw a line, okay, I have error. So what I will do, I actually plot the error when I change here. This one, sorry, is the formula here. Y equal to ms plus c. I do not know what's m. Okay, so I will draw many lines to find what is the best value for m. Okay, so the m is the w just now. Okay, so by changing the m or the w here, I will know where is the least error. Okay, so this is, I can actually plot a graph like this. So let's say I'm here, my w is here, or my m is here. Okay, I want to go to here. Why? Because this is the least error. Okay, so what I do, I'll measure the gradient. Okay, why somebody draw or not? Okay, so I'll measure the gradient. So what's the gradient here? Remember your home for secondary school. What's the gradient? Is it negative or positive or zero? Keturunan. If you remember your BM. What's the gradient? Is it negative, positive, or zero? Negative, isn't it? Okay, it's a negative gradient. Okay, so this is a negative gradient, and you want to come to here. If you come to here, what's the gradient? 0. So you want to go to gradient 0. So what that's how the line will do, will change the value of the W to go to 2. Okay. So you go to here where the gradient is 0. So this is the minimum error or minimum cost. Okay. Same, if my line is here, my W is here, my gradient is positive. I want to go to here where the gradient is 0. Okay. Okay. Then you will find this is the value of the W where the error is missing. And this whole process is called gradient descent. You probably hear about this again many times when you do deep learning. So the purpose of gradient descent is to find or to minimize the error, to change the variable to get the least error. Okay? And this is all done by machine learning. So you can start off with somewhere, and then your machine will change multiple variables at the same time. So you can achieve the minimum. Okay? So now your line has plot. This is the best line. This line is what we call orderly least square line, where this is the best approximation of the formula just now. Now you have the formula. Now with this formula now, when you have a house, you can now predict the price. Okay? You can predict the price. And all this is done by your machine learning model. All you need to do is select regression model, feed in the data with the label data, then you will be able to learn the model. Then now if you feed the new data, you should be able to do prediction. Okay? Any questions? Is it too high level or too simple for you? Somebody is like, oh, this I only know long time ago. Too simple for me. Okay, if no question, we move on to the second supervised learning, which is called classification. So classification, what's the difference between classification and regression? Classification is again for supervised learning, label data, but because now the label is discrete data. For example, 0 or 1, or label A or B or C, or label has defect or non-defect. Okay, so when you see label like that, discrete, then you need to do classification. Okay. Then some people ask, can I change regression data to classification? Can you? Can you do regression, change regression to classification? Okay, for example, data here. Let me show you the back to data again. Okay, how to change this label data to classification? How? Is there any way to change?
Can be like ranges of prices.
Yep. So for example, I say 100,000 to 200,000 is low price. Then now we change from a continuous value to a discrete value. Then for example, 500,000 to 700,000 is medium price. Anything more than 700,000 is high price. Then you have three labels. Then you will change your data now from regression to classification. Okay, you can actually change the data from regression to classification, change the continuous value label to discrete value. Okay. Okay, so what is classification? So classification is to predict a group or class. So the output will be discrete value or categorical value. Okay, for example, you look at this classification image here. You can separate now all the plus symbol and the circle symbol. So let's say I have a new dot here, down here. I will classify this new dot as circle. If anything that is above this dotted line, I will classify that as a plus. Okay, so your model classification is to find the line to separate these two data. Okay, so this is what we call the separator or in the machine learning term, the classifier. So the classifier is able to determine from data, able to help you to do classification. And this is the regression system. You have many dots. Your job is to find the best line to represent the relationship. Okay? Okay. So how does the classification data look like? Because something like this. You have a gender, you have age, and what drink do they drink. Okay? You have Coke, Coke Light, and orange juice. Okay? Coke Light, orange juice. Okay? So in data, what do you need to do? You need to label this as numerical value. Because you cannot put a Coke with the data in machine learning, data science, all the values must be numbers. Okay? You cannot process alphabet. So for example, you have to code this into alphabet in numbers. Okay, male 1, 0, 4. Change this also. Okay. So let's say I use label 1 for Coke, Coke Light 2, and then orange is 2. Okay, yes. Previous data the same number, what do you mean? Yeah, but other label is it drinks or not? So if for this column, you can use 0, 1. Of course, you can other column. You can other column, for example, maybe income level, education level. You can use that 0, 1 also doesn't matter. Okay, but every single column, every single one you call variable. Okay, you can use that numbers. You can repeat. Of course, you can say or drink. I only use 1, 2, 3 to represent drinks. The other column I cannot use 1, 2, 3. No. Okay, that variable you can use but this is what we call encoding. Encode the label into numbers. Okay, is it clear? Okay, so this is the label. Okay. So the question now is, look at the data here. Okay. Between gender and age, which one is more decisive or able to help you to predict which drink the user will choose? Is it gender or age? Okay, some say age, some say gender. Okay, and look at the data. We have 3 columns on it, and then we have 1, 2, 3, 4, 5, 6 rows. We can just eyeball and see. But normally in the real world data have millions of rows. You cannot eyeball. Okay? Imagine you want to look at 1 million rows and determine whether gender is better. You go crazy. Okay? This is where the machine learning comes in. You look at data, it helps you decide what is the best variable to determine whether age or gender. Okay, able to predict what drink they will be. Okay, so let's look at gender. Okay, female. Some drink Coke, some drink Coke Light, some drink Coke also. There's no clear separation. When you look at age, what can you see? What can you see? What can you see? So is it gender or age matters? Age is it? From here you can see, if I'm below 18 years old, I'll drink Coke. And if I'm below 20 years old, depends on whether I'm male or female. So from here, the machine learning model is able to find how to separate these data and do a prediction. Okay? So this machine learning model is called decision tree. Okay? So the decision tree, okay, you're able to look at data, millions of rows, and find the best way which of the variables you're able to separate clearly and able to predict for me in the future whenever I will use it. Okay? So something like this. If I'm below 20 years old, I'll drink Coke. And if above 20 years old, depend on gender. If female, I'll drink Coke Light. If male, I'll drink orange. And this whole thing is automatically determined by the machine learning model. Of course, this is very simplistic. Sometimes it's not so easy to separate it. Okay? And sometimes the machine will output many different trees. Then you will find the best tree that can able to give you the best or minimize the error. Okay? So now, with this decision tree, you have a new data. For example, I have this guy here. Okay? So this guy is more than 20 years old and he's a male. Then I will know that this person I will predict will drink oranges. Okay? Then let's say I have this baby girl. This baby girl I know is less than 20 years old. You will predict you will drink Coke. Okay? And then let's say I have this lady, because it's more than 20 years old and the gender is female, then I will predict you will drink Coke Light. Okay? So this model is called decision. Okay? Okay. So the decision tree is a model where, looking at the prediction model, you will look at observation and you try to build many branches to help you in the conclusion to do a prediction. Okay? So in many companies, long time ago, they will use the decision tree to actually process whether to approve loan or not. Okay? So if you go to the bank, still a lot of banks, they use decision tree to determine or do an early decision making whether to approve your credit card or to approve the loan or not. Okay? Sometimes there are some people they keep on applying credit card, they keep on failing because the decision tree has some rules that you probably not qualify for the loan or not qualify for the credit card. Something like this. Okay. So what's the good thing of decision tree? The good thing of decision tree is you can see how the model predicts. You can explain the model. Okay. So a lot of times people say, tell me why the machine predicts like that. Then you can go back and look at the decision tree. You can see how the machine makes decisions. That's a good thing of it. Okay? Okay. So we look at data like this. Let's say we have data like this, some label as red color, some label as blue color. Okay. And then what the machine learning will do? Machine learning will learn and build a classifier. Okay. So you actually look at, let's say I have a data point here. This green dot here. This green dot here, should I label as blue or should I label as red? Okay. How do I know? Okay. So imagine, for example, let's say I want to build a model to recognize whether this patient has lung cancer or not. Look at the image data. Okay. This is very serious case, isn't it? I trained my model already. Now I have an X-ray, chest X-ray. I want to ask the model to tell me whether this person has lung cancer. Look at the new image, X-ray scan. So your model is able to learn from all the previous X-ray images and learn what is cancer and what is non-cancer. Okay. So now I have a new image. I want to predict, the model to predict whether this is cancerous or non-cancerous. Okay, so what your machine learning will do, you just build a classifier. Then because this dot is at this side, then I will know this dot belongs to the blue circle. Okay. So you just classify this green dot to be blue. Of course, you look at this classifier, there are some red dots here classified as blue. This is what we call error rate. You cannot find a line where you can manage to separate one. So there's some error. So you can say 99.999%, not 100%, my model able to predict something. Okay? Okay, so just now, you can easily draw a straight line. But sometimes in real life, it's not so easy to draw a straight line. Okay? For example, this data point here. If I draw a line like this, arrow, this red color arrow, this red color arrow. Because some are this blue color arrow. Okay? Then I can draw another line. Even worse. A lot of these blue dots classify as straight arrows. Okay, so I can draw another straight line, another arrow, many arrows. Okay, so clearly, this data set, I cannot draw a straight line. Okay, so how do I separate this data? The best way is to draw a curved line. Okay, but for machine learning to draw a curved line, it's not so simple. Okay, this is where we have a technique called support vector machine. Okay? Support vector machine is where you do a data that is non-linearly separable. You cannot separate using a one straight line. Okay, so basically what the SVM, a support vector machine, will do, for example, you have many data like this white circle and this black square. It's not a straight line. But you want to draw a classifier to separate the white circle and the black square. Okay, how do you do it? They will actually do something what we call kernel trick. You leave this black square to another space. Then you can separate them. Then you can draw something what we call hyperplane. Okay, so this is done automatically by the SVM, and they're able to help you to classify non-linearly separable data. Okay, let me show you the video. It looks something like this. So you have a data point here which cannot be separated by a linear line. So what the SVM will do, you actually try to leave all the data points into another space, the blue and the red. Then you actually separate them with something we call hyperplane. Now you can classify those data points on top will be blue, what those below will be red, which is your classifier, which is a circle. Okay, and this is done by your machine learning model. Okay, so sometimes you look at the data, you cannot separate, you cannot achieve a good result because it's not linear separable. You might want to try out SVM. Okay, so SVM is a classifier where you separate by hyperplane. Okay, so something like this. The data can be separated using a straight line. You use SVM. Okay. Okay, the last one before I take a break is what we call logistic regression. Okay, this is the common interview question. Because people look at the regression, so everybody think about y equals to mx plus c. Okay. So logistic regression is a classification. It's not regression. Okay. Even though the word regression there is a classification. What's the classification? The label is discrete. The label is discrete. Okay. The label is a class. So a lot of time when you go interview, most of the interview ask you what's the difference between regression and logistic regression. Okay. So the difference is for logistic regression is the classification. Okay. Because the label is discrete. Okay. So why is it like that? For example, I have a label here, class of fish. So this label is discrete, isn't it? It's a class. Okay. And how is it? Because certain hour when I study, for example, gender, number of hours study. Certain hour if I study, if I don't study enough number of hours, I will fail. But if I study greater than certain hours, I will pass. So the graph is not like a straight line or a it is like what we call a sigmoid graph, S curve. So for this S curve, there's only two values, the label, part of it. Okay. So your label will be something like, let's say I have something here. Okay. Let's say number of hours I have something here. Then I will look at whether I pass certain hours, then I will classify as pass. If it's below certain hours, I'll classify as fail. So logistic regression is where normally your label is these two labels, binary labels. Okay. So logistic regression is the method we determine the variable, the outcome. Normally is dichotomous, means binary, 0 or 1. Okay. So if I look at the data here, so let's say certain value, I'll get y equals 0. Certain value of x, I get y equal to 1. If I draw a linear regression, I draw a line like that, I cannot able to represent this data. Okay, I only can represent this data if I draw a S or sigmoid graph. Okay, so for logistic regression, usually you see this S where the label is either 0 or 1. Okay, any questions? Too much information. See, machine learning sounds like machine very simple, and now human is suffering. Okay. Okay, maybe I take a 5-minute break. We'll come back again. I can see people now. But you're just sitting down and be talking for 1 hour. Yeah. Yeah, I know. I also saw the slide. I'll answer that. Okay, shall we start? I was told there's a lot of questions I need to answer. Let me answer some of them. Okay, first question, how important is statistics in learning machine learning? Okay, I'm not sure whether you have seen the Venn diagram for data scientists. So you need to know programming. you need to know machine learning, you need to be good in math and stats. Okay, so towards the end, math and stats is one of the fundamental machine learning. Especially if you do deep learning, there will be a lot of problems. Okay, so last time your teacher never tell you that one day you need to learn back statistics and math because you want to learn machine learning or learn AI. Okay, so it's quite important. Okay, so would you say if I don't know statistics or if I'm not good in math, can I be good in machine learning? Yes, you can, but sometimes you need the fundamental to explain why the model is behaving like that. Okay, you also need the statistical knowledge to help you to process the data. Okay, so in a way, it's quite important. Okay, because once you understand the fundamental, you start to appreciate what the model is telling you. Okay, so this is the problem sometimes. Last time when we study math and stats, prof and stats in the school, our teacher just tell us to derive formulas, which is very boring, and we don't see the importance. Now we see the importance. Okay, because when you apply something, then you know it's important. Okay, second thing is it possible to get 100% accuracy in prediction? Okay, I can say it's possible, but sometimes later I explain. Sometimes we have something we call overfitting. When your model overfitting means always give you 100%. Then there's something dangerous. Okay, that's why nobody will pay. Even human cannot say I'm 100%. Especially people say I'm 100% tomorrow you'll hit lottery. It's never 100%. Okay, so 100% is not something you want to aim for. Okay, it's not based. Okay, how do I think whether I apply this appropriate? Because I'm not the calculation. Next question is, if not mystical, it's hard to get real data compared to test data. How to get real data? Okay, later one of the slides I will tell you where to get the data. It's true because data is what we call data is a new oil, petrol. Okay, why do people start collecting data? Because data is very important and data is valuable. Why does Facebook give you a lot of free services? Give you Instagram for free, give you use Facebook for free, give you use WhatsApp for free. Why? Because they are collecting data about you, then they can sell ads about you. Okay, so if I'm a company, I wouldn't want to give you my data because it's something valuable to me. That's why getting real data is complicated. It's not easy. Why should our training accuracy be higher than our validation accuracy? Okay. Why should our training accuracy be higher than of course when you train data, okay, when you train you can actually fine-tune your model until your model fits very well to your training data. But when you have a testing data, the data never seen before, never trained before, usually the accuracy is low. Okay. Next question, is it true object detection can't run training and validation parallelly? No. Later I'll explain there's something called data linkage. Okay. You cannot train. Okay. If you already have a model trained, then you can actually do validation parallel. Something what we call just retrain the model. Is it possible for someone with non-trained background ICT to learn machine learning from experience? Learn machine learning from experience. You mean like just now I tell you how humans learn. You want to experience machine learning. I don't know how to learn. But you cannot experience machine learning because machine learning consists of programming. Okay, you need to learn from that. Okay. Kenapa? Wow, this is very high-tech question. Kenapa people straight away jump to TensorFlow Python? Somehow neglect basic machine learning, like decision tree SQL. It's true. A lot of people now, like I said, because it's a hard learn, People all talk about TensorFlow, Python, straight away jump to deep learning. Okay, and then they don't know the basic learning. Okay, later, in one of the tips I will tell you, always start with the simplest model. Okay, that's one of the tips I will give you later. Never do deep learning, because deep learning, it will actually take out a lot of resources, and all these complicated models, they are very data hungry. They need a lot of data. Okay. So when doing machine learning, can we just insert data into existing models? What do you mean by insert data? You think the model makan data? Cannot. You need to train the data. Okay? You need to train the model. So I don't know what you mean by insert. You talking about feeding the model. Right? Okay. Don't treat all these machine learning models like human. Okay, I just thought I give a comparison. Human learn from experience, model learn from data. Don't think like they are human. Feed them data, they eat a lot, then they can get it. Okay, next question. How about logistic regression needs some adjustment for confounding effects? Further fit the data. Okay, so the logistic regression later, based on the model, you actually learn what is the value to split, okay, from the this variable, whether to label as 1 or 0. So your voice is not still very clear. Okay, cannot be. I'm not a singer. This is not a quality mic, so too bad lah. Sorry. I'll try to do better. Just looking. What are the limitations of deep learning? Okay, limitation of deep learning is deep learning, like I said, is very data hungry, take a lot of resources, and resources is all training time. Okay, you probably heard about people buying GPU to train deep learning. Okay, and then the data is a lot. Okay, sometimes you just need to do regression. Why? Because of MX plus C. But then you go do deep learning. Okay, so that's the limitation. Very data hungry, need a lot of label data, and you will not necessarily get all the label data that you. Okay, I will just finish 2 last questions, then I'll go back to the top. I'll continue the other questions. What's the next step after taking this course? As the self-learning to do to be data learning? If you finish this course, it's considered very good, because you see the course. You have programming, you have pandas, you have machine learning, you have data visualization, you have SQL, you have deep learning, you have computer vision, okay, all the way to intro to game AI reinforcement learning. If you complete everything, it's considered very good, and start to apply it. Okay, learning is a never-ending process, but people need to apply. There are some people keep on thinking that I need to get more certificate. But when will you apply? Okay, apply. Go and find a job. Apply it. No, see whether what you have learned is it enough, sufficient knowledge. Then learn while doing the job. Okay, getting certification is just building the fundamental. Okay, a lot of people want to get certificate, keep on chasing certificates. Not relevant. Okay, how long can you chase certificate? Go apply, do a real job. Don't be a coward. Do the thing. No. A lot of people just show off that I know this because I have this certificate. Don't talk, do. Okay? That's one thing I will tell people. Okay, if you have finished this course, go get a job. Okay, prove that you can do the job, apply it, and progress in your career. Okay, that's our advice. Last question before I go back. What are the ways that you can operationalize machine learning models? There's something what we call MLOps. If you go and Google, MLOps is something where we call machine learning operations. We talk about operationalize the machine learning or deployment. Okay. So after you learn all these fundamentals how to apply, the next step is learn about MLOps. MLOps will help you to operationalize the machine learning model. This is very important, isn't it? We can build many models, but if the model is not deployed, especially in the company. Your boss tell you, what have you been doing? I built many models. I built 50 models already. Then your boss tell me, how come the company not seeing it? Because I haven't deployed. Okay, then the boss will fire you, wasting time. Okay? Employ you 2 years, I haven't seen a single thing. Because model deployment is very important. Okay, deploy the model. Then people can see how good is the model. If the model not good, go back and fine tune the model. Okay, you can only see the model after you deploy. Because once you deploy, the model will predict unseen data, real world data. Then you will know how good is the model. Okay. So those questions that I haven't, I'll come back again after I finish this talk. Okay, the next classification we have is called KNN. K nearest neighbor. The K means how many neighbors. Okay. The K means how many neighbors you will use to do a classification. Okay, look at this diagram here. If I say K equal to 3, okay, K equal to 3. The red dot here is the one I want to classify. Okay, and I have two classes, the yellow and the purple. Okay, so I will use the K value, whether K equal to 3, that means I take 3 dots to determine what class. When I say K equal to 6, that means I use 6 dots. 6 data points. When I say K equal to 3, so the red dot, when I say K equal to 3, what do I see? The nearest neighbor. I see 2 purple, 1 yellow. That means majority purple. Okay? Then I will label the red dot as purple. Okay? When I say K equal to 6, that means now I take 6 nearest neighbor dots. Okay? When I take 6 nearest neighbor dots, what do I get? I get 4 yellow, 2 purple. Alright? Then the majority now is yellow. Then my red dot will be labeled as yellow. Okay? So by looking at how many K values that I use, my class can choose. Okay? So that is K nearest neighbor. Look at this diagram here. So the black dot, you just look at the number of neighbors and look at which is majority, then I'll classify that dot as that class. That's K nearest neighbor. Okay? So for this case here, we're taking 2, K equal to 2. Okay. So one fun activity, what you can do, if you are bored at home, nothing to do, you go to this machine, teachable machine. So teachable machine is where you can actually train the machine online on the spot. Okay. So let's say I want to train image project. Okay. So let's say I want to train my image project. Okay. I'll use my webcam. So let's say I want to train this with a mouse. So I'll hold the mouse like that. Then I'll hold the record button. So, okay, so what I have done is, okay, I have trained the image of the mouse on the spot. Then I can label this, as mouse. Okay, now I want to add another data point. I want to train now my phone. Okay, so can you see now what I'm doing? I'm providing a label data. Okay, I'm providing a label data. So I have 42 images of a mouse. I have 45 images of a phone. So label is phone. Okay, then what I do, I provided two label data, I'll train the model. So now it's training the model. So after I train the model now, if I show this, you can see, you know this is a mouse, 90% is a mouse. If I show this, you know that 100% is the phone. Okay, so it's actually trained on the spot. Okay, so if there's nothing to do at home, what you can do is you can train, for example, your front gate for people or no people. Then because people come in, then you can, because you can actually turn on the sound, you can actually alarm. So you can create a CCTV at home using your website. If there's nothing to do at home, I'll go to that. Other thing you can do, you can actually train audio project, or you can actually do a post. Okay, so you can actually again. So you can see now you can detect my face, you can detect my body. So what you can do is you can stand out and do a yoga pose or do a golf swing, then you can detect your. And this you can do training on the spot. Okay, so there's a fun thing you can do. But towards the end, what you can see is you actually is providing label data, and then what the machine is doing is just doing classification. Okay. Next, we have clustering. Clustering means we have unsupervised data, no label. Okay. So what clustering will do is you have a data, there's no label, and you want to ask the machine learning to label them, to group them together. Not label them, group them together. Okay. So for example, you have all data points like that. Okay. Then your machine learning will, based on the model, you try to group them together. Okay. So one of the techniques for clustering is called K-means. Okay. Again, you have another K value here. This is another typical interview question. They ask you what's the difference between K-means and K nearest neighbor. A lot of people confuse them because they think about the K value only. So what's the difference? K-NN and K-means. What's the difference? Imagine if I ask you, tell me what's the difference between K-means and K-NN. What do you think is the difference? Wow, so far forget. We just did K-NN just now only. What's K-NN? What's the difference?
K-NN is one of the neighbors of the issue. K-means is what is the meaning of the issue.
Not very accurate. Anybody? I want to target those people who attended this class before. Sean, what's the difference?
K-means is like the neighbors operating as the team for the K-means is the partition, like how many parts they want.
Okay, that's the easiest question, the easiest answer is what actually? Who can give me the easiest answer? Now we're coming to physical event. Zoom people can just ha 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 I see a phone. The major difference is K-means is unsupervised. K-NN is supervised. Okay? So K-S is the label data. K-means there's no label data. Okay, that's a major difference. Okay, so remember that. Okay, okay. So using K-means, we have unlabeled data, unsupervised, then we do cluster. So K-means, okay, will help you to do cluster. Okay, so can you convert unsupervised data to supervised? Can you? You have no label. Can you convert to label data? Can you? By using what? Using k-means. Okay, once you cluster them, you see, for example, like just now, I have Shopee data. Then I see there's certain people behavior, they buy things at 11 o'clock. Then I will probably label them as 12. Then they're labeled already. That means you successfully using group clustering to convert data or give them a label. Then it becomes a group. Of course, the label, you might not be, you might not know whether it's correct or not. Because they have a certain behavior, they group together, but you do not know whether your label is correct. But at least you can convert from unsupervised to supervised. Okay? So how does the k-means algorithm work? So you first determine the k value, how many groups that you want. So for example here, you determine that you want 3 groups. So the algorithm will find the nearest point, and then they'll move the center, and then they'll calculate again the nearest point. Towards the end, sorry, the k here is 4. Towards the end, the algorithm will converge that now are 4 clusters. Okay, you automatically determine it by itself. Okay, so the next question you ask is, how do I know what is the number of k that I want? You never know. Okay, you can try. Of course, you cannot say k equal to 1 now. If k equal to 1 means what? All the data is 1 cluster. 1 point is 1 cluster. Let's say you have 1 million points, you have 1 million clusters. That's the kind of stupid. Okay, so at least k must be greater than 1, start with 2. That means 2 points to make 1 cluster. Okay. Okay, next we have what we call reinforcement learning. Okay, so reinforcement learning, okay, like I said, the word reinforcement learning. So reinforcement learning is not something like we explained it. We try to mimic how we reward or how we feedback to an action taken by the machine. Okay, if the machine behaves in the correct environment, taken the correct action, then you reward the machine. If the machine taking a wrong action, then you punish the machine. So after some time, the machine will try to learn how do I best, what action should I do to get the most reward. Okay, so sounds simple, isn't it? Like I said just now, like it's a small kid. If I behave correctly, I'll get reward. If I don't behave correctly, I'll get punishment. But you need to define what behavior that determine right action, then you give reward. So your job is to determine the reward and the punishment. Okay? So in what kind of situation people will use reinforcement learning? Situation like, I don't know whether you heard about AlphaGo, the computer, the best human chess player, Go chess player, that is using reinforcement learning. There's a company called DeepMind, now it belongs to Google. It developed a program called AlphaGo. It beat the best Go chess player using reinforcement learning. That means what kind of move that I make in the chess so I can get the most reward. So that's reinforcement learning. So basically something like this. I see fire, I see water. What action should I take? If I go to the fire straight, I get a penalty. I'm minus 50 points. So in the future, I know that I should not go to the fire first. I should go to water. Okay. So that is the basic concept of this reinforcement learning. Okay. So of course, you have to define what's the penalty, what is the wrong action, and what's the reward. Okay. I am not sure whether you've seen this video. This is the early version of the program by DeepMind. They actually trained the machine to play this game. So it actually play Atari this game. So this machine have never learned anything about this game. It's just based on the pixel on the screen. Okay, they have no knowledge how this game works. The only reward is make sure I keep the highest point. Okay, make sure I keep the highest point for the game. Okay, so the first 10 minutes, the machine doesn't know what to do. The ball keep on dropping. Okay, so after some time, you learn that I should learn not to drop the ball, so I get the highest point. So after 2 hours of learning, you can play like expert already. So now you will not drop the ball, and then you keep the highest point. Okay, so it's very good for expert already. You learn by yourself. And after 4 hours, you will find a loophole already in the game. For the loophole, you look at you keep until a point where it doesn't need to hit the ball will hit by itself. Okay, so there is reinforcement learning, that early stage when we use the reinforcement learning. Okay. Okay. So to do machine learning, there's a few things that we need to follow. We have a machine learning framework. Okay. First, like I said, must have data. Collect your data. Then do data pre-processing and select the attribute that you want. It means a column. Like just now, we have gender, we have age, we have room size, we have room. Select the attribute. This is very important. This is what we call feature engineering. Later I explain to you. As a data scientist or AI, sometimes one of the problems that you have is you have too many data. Okay, too many data means what? 1 million row and 300 columns or 500 columns. Okay, cannot imagine that. Okay, so you cannot fit all the data into your machine learning model. First, not all the data are relevant. Second, you fit all the irrelevant data, your machine will be your model will train long time. So you need to select the attribute that you need. Then train your model, or sometimes we call fit the model. Then you store the model. You could have many different models. Okay, so you want to find the model will give you the best score. Then apply test data and predict output. So this is the common framework. Okay, so first step, collect data. So there are many data, like we said, if data is not available, then you cannot train the model. But you also cannot fit all garbage data. Remember, we study IT and garbage in, garbage out. Data that is not good fit the model also will produce bad results. So there are many open data sources out there. For example, UCI, Kaggle, or you can use Google data search. So if you go Google data search, there's a search engine just to search data. Okay. Or you can see a lot of government data. So Malaysia, we have data.gov.my. But don't be surprised, it's not very good. So go to data.gov.my. So this is the initiative by the Malaysian government, where most of the government entity will want to share the data. Okay, it's not even loading. I'm not sure whether it's blocked by SunRayU or not. That's not loading, but it's supposed to be data.gov.my. You can see Malaysia data. Okay, next, pre-process data. Pre-processing is very important. You need to transform the data into something readable format. Okay, and then you need to able to make predictions. What kind of pre-processing that you need to do? You probably need to handle missing values. There are some data where the cell is empty. Okay, what do you do with it? Do you delete the whole column or delete the whole row? What do you do? So there are a lot of skill sets. How do you handle missing values? What do you do? Okay, if your data has a lot of missing value, then you need to do something. Because you cannot just simply delete the row. Because if you delete a lot of rows, then your data becomes smaller. Then you reduce a lot of information. Okay, how do you deal with outliers? Okay, your data is from the range 1 to 10. Suddenly you have some raw data 500. Okay, how do you deal with outliers? Data that's out of the range. That's what you call outliers. Okay, then you have you need to split the data set from training, testing, or validation, and sometimes you need to scale your data. Okay, for example, most of the data is from 0 to 1. There are some data from 500 to 1,000. The range is different. You need to normalize the data into same scale. Okay. Then you need to choose your model. Different model depends on the data. You need to choose whether you need to use supervised learning, unsupervised learning, or reinforcement learning. Supervised learning, that means your label data. So label data, what can you do? You can do regression, you can do classification. Unsupervised learning, you can do clustering. Okay. Then you train your model. Okay. In machine learning, we fit the model. You train the model. Okay. After you train the model, you evaluate your model. Okay. You can try many models. Like just now, we can try KNN. We can try SVM. Okay. You can try decision tree. So you will try to see which model gives you the best result. Okay. So after you look at the model, sometimes you need to fine-tune your model. Okay. This is what we call hyperparameter tuning. Okay. Hyperparameter tuning, that means there are certain things that you can tweak in your model. Okay. For example, KNN, we can play around with the K value. K means we can play around with the this K value also. Okay. So these are the parameters you can actually play around to improve the model. And lastly, do prediction. Okay. After your model, you just deploy it, you need to do prediction. Okay. You predict data which is unseen data. Okay. So that is the normal framework of a machine learning framework. So what are the libraries that I will use? Okay. The library here is quite extensive. You do not need to learn all, but the majority that you need to learn, for example, definitely you learn NumPy. NumPy is stands for numerical Python. Okay. A lot of people like to pronounce this as NumPy. I don't know why, but the word here is numerical Python, Pi. So it's NumPy. Okay. Okay, so NumPy will allow you to process data in array or matrix. Okay. Then there's SciPy, which is for scientific. Okay, to do all the scientific calculations. Then there are pandas. Okay, panda with the S. Okay, so pandas actually come from two words. The pandas is actually meant for tabular data. Okay, so data in the form of row and column, or what we call data frame. So most of the data that you go and process are in the form of row and column data frame. Okay, then you will probably learn about scikit-learn. Scikit-learn is the most popular machine learning library for Python. Okay, then we have matplotlib. Okay, matplotlib is for to visualize, to do a graph or chart. Then we have the most higher level deep learning framework. We have TensorFlow, Keras, and PyTorch. Okay, you will probably ask, do I need to know TensorFlow, Keras, or PyTorch? All three of them? No, but I think the easiest way to learn is just use Keras. Okay, Keras, you can actually is one high level API that you can actually run on top of TensorFlow or Python. Okay, so congratulations, you already know basic machine learning, supervised learning, unsupervised learning, reinforcement learning. You can say you can go and find a job at data scientist. Okay, so let me now tell you what are the tips, okay, that you probably need to remember when you go on the journey with this data science of the student? So what is the general tips? The first tip is I will tell you that what most data scientists will spend most of the time. You look at the pie chart here. 60% of your time is to do cleaning and organizing data. Okay? So don't think that if I'm a data scientist, I'm a scientist, I create rockets. But most of the time you're just a cleaner, janitor. You spend most of the time cleaning and organizing your data. Okay? Your data don't come to you nicely in the table format. Okay? In my company, sometimes we spend 3 to 4 months to prepare the data, or even longer, because the data needs a lot of cleaning, mapping. Okay, make sure it's in the right format. And the data is so huge. It's not like, oh, I just click one click, it will do everything for me. It takes a lot of steps to do. Okay, for example, I want to replace a value, or I want to change a certain value. Because the data is so huge, 30 million row of data, it's not so easy to do. One single action sometimes can spend like 8 to 10 hours per day to just do one thing. Okay, so that's why it takes a lot of time. Second thing is, what is the least enjoyable part of data science or AI? Again, you're probably doing a lot of cleaning. More than half of your time will be spent on doing this. Okay, so you think your job is very happening? No, most of the time you're just doing cleaning data. Okay, so my tips for you so you look at it. Another thing is 80% of data is unstructured. Unstructured means what? Not in data frame format, not in row and column, not nicely stored in database. Okay, you need to access a lot of data that is unstructured. Okay, JSON format. Okay, very complicated. Okay, you look at all the tagging. You also want to copy the. Okay, people who do all this JSON, they will know. Okay, so it's very unstructured. Okay, that's where a lot of things that people are doing. Like for example, I need to use MongoDB because it's unstructured. I need to use NoSQL. Okay, because it's not stored in normal SQL. I need to use all this NoSQL to access my data. So the first thing I will tell you is you need to know feature engineering. Okay, what is feature engineering? Feature engineering means you need to process your data to make sure it is in the very ready format. Okay, so you can fit into a model to do training. The second thing is feature engineering helps to improve the performance of the machine learning, improve the accuracy. Okay, so what are the things that you need to do? For example, imputation. What's imputation? Okay, imputation means how to deal with missing values, or how you want to remove certain values, how to handle outliers, how to bin your data, how to split your data, how to do scaling. So there are many skill sets you need to do, okay, before you can train the model. Second tip is, okay, you need to split your data into training and testing and validation. Okay, so you need to split your data. So normally, if you have a data, 80% I will train the model. Another 20% I will do validation to assess the data. Okay, and this validation or testing data must be unseen, never seen before in the training model. Okay. Another thing is we need to be careful is we have something called overfitting. Overfitting means what? Overfitting means your model, you fine tune. It works very well in your training data. Work very well. You're very happy. Initially it was 80%, you fine tune until 99%. 99.99%. You're very happy. Say my model accuracy is 99.99%. Okay. But then when you deploy your model, you see your model sucks. Why? Because your model only works very well in a training environment. When the real environment, then it doesn't work well. Then we say your model is overfitting. Okay. There's a certain model what we call underfitting. Underfitting model means your model sucks, doesn't work. Okay. So basically like this. When you're overfitting, you look at this diagram here. When you're overfitting, your line is like, wow, try to separate every single dot, but this line is too perfect. So it only work for your training data. Okay. So you want to build a model, what we call generalized model. Okay. So you want to build a model where you can actually do a generalized model. You can actually work very well in the training environment. You also should work very well in the testing environment. Okay. The next tip is, I will tell you, try the simplest model first. What's the simplest model that you know? Regression, isn't it? Okay. Because if the simplest model can give you accuracy 90%, then why you want to do other complicated models? Because the simplest model can give you reasonable good result, then okay, that can be used as a baseline. Okay, if you spend like a lot of computing resources, and then the complicated model cannot even beat your baseline model, that means something wrong. Okay, so always start with the simplest model. Okay, so the simplest model will give you an estimate of how much performance can you increase or can you improve. Always remember, complicated model will have a trade-off. What's the trade-off? So normally complicated model need more resources, need more time to train. Okay, need more complicated data. Okay. Next thing is model explainability. Okay. A lot of times we need to choose a model that people can understand and easy to explain. This is very important because when we work as a data scientist or we work as an AI scientist, we need to explain our model to our stakeholders. Okay, a lot of times they ask you why the model predicts that issue. You say, don't know, the model said like that. Then I will say, why the result like that? Don't know, the model said like that. Sooner or later they say, I fire you, better just ask the model. Okay, you need to explain the model. Okay, the model cannot be explained is what we call black box model. So black box model means you do not know what the model do, but get result for you. So black box model is very difficult to debug because you do not know what's causing the error and you do not know how to debug it. Okay? Especially you work in a regulated environment, regulated company. For example, you work in a bank, you work in an insurance company, you work on a finance company. A lot of time all these models need to be explained. Okay. Next thing is avoid data leakage. So what is data leakage? Data leakage is when your data that you use in your testing leak to your training. Okay. For example, I have a data that says I put an IC number data in my training. Let's say. Then I want to predict this person is a male or female. It's already easy to predict, isn't it? Why? IC number, how to predict male or female? Yeah, the last number, isn't it? Okay. So that is already a leakage because the data is actually leading to your prediction. Okay. Or for example, I have a data of a patient taking certain medicine. Then I want to predict whether this person has diabetic or not. There is also data leakage because certain methods that people take can predict that person got diabetic or not. Okay, it might not be so direct, but certain data can actually lead to the machine to learn the pattern and able to help the prediction. That's called data leakage. Okay, so a lot of times we are so happy our model performs very well, but actually not. Actually, the model able to learn from data and just do a simple prediction, matching pattern. Okay, so this takes some time for you to learn that we have to prevent data leakage. Okay. Another concept you learn is we need to identify what data drift and concept drift. So what's data drift? Data drift means the data will change according to time. Okay. For example, I train to recognize I will train to recognize alphabet character. I train all the data like this. But then when I deploy my model, people feed in data like this, which is all colorful. Do you think my model will perform very well? No, isn't it? Because he has never trained all this production data. Okay? So you need to change your environment when the data has changed. Okay? So you need to retrain your model. Another thing about concept drift is, okay, another thing about data drift is sometimes the data change because of seasonal change or consumer behavior change. For example, during 2020 and 2021, compared to 2019, do you think there's a data change for consumer online behavior? What's the change? What's the change? Anybody can tell me what's the change?
People buy more stuff online.
Yeah, because we are COVID, isn't it? We tend to buy things online. Okay, like recently, if you read a lot of data about this Grab food delivery or food panda delivery. People going back to office. You think they'll still order Grab food? The sales drop. Why? Because the behavior changed. Okay, last time you can predict, at this hour this person will order something because he work from home, because lifetime cannot go out. But now the behavior change. Okay, so seasonal change will lead to the model have to be trained again. Okay, so there's data drift. Okay, concept drift is the model, the target also change. Last time you want to predict, for example, credit card fraud. Now your model you want to predict whether this person is has a high credit score or not. Okay, so the way that you want to use the model has changed. So if you detect whether you have data drift or concept drift, you need to retrain your model. Okay, so model is never stagnant. You cannot say I train one time the model, then I can actually use the model forever. You need to detect whether there's data drift or concept drift, then you need to retrain your model. Next thing I want to tell you is there's a lot of people last time concentrate a lot of models. Oh, I use TensorFlow, I use PyTorch, I use SVM, I use random forest, I use GBM. There are many models out there. I change from one model to another model. Okay, but towards the end, whether what model that you use, if your data is not properly labeled, then your model will not improve anymore. Now, there are people, they say, I better focus on the data first. That's where we call data centric. That means getting the right proper label data is more important to choose the right model. Okay, just like when I want to draw a box, okay, of label or photo, how big is the box determines how good is my label. Okay, so data centric now will tell you that having a good data is more important than having a good model. Okay, so now there are a lot of movement out there to tell you what's the standard to label data and how to make sure the quality of data out there that you have. Okay, next thing I want to tell you is machine learning is a team effort. Okay, in machine learning in the commercial world, you have people like data scientists. You have a team of people consist of data engineers, machine learning engineers, subject matter experts, dashboard visualization. So normally a data science team will have many people like this. Okay, so one person cannot do everything. Okay, for example, I want to deploy the machine learning model. Or I'm already a data scientist. I'm so busy training model. Do you think I have time to deploy model? And after I deploy model, do you think I have time to monitor the model? So normally, in the commercial world, there's a bunch of people, okay, and specialized. But too bad if you work in a Chinaman company, you're one big kid and you do everything. Okay, so that's why now, if you go out and look at the advertisement, there are people saying, I want to employ machine learning engineers. Okay, And then you see what's the difference between machine learning engineer and the data scientist. Of course, machine learning engineer, if I go to apply, I will expect you to know how to deploy a model. Monitor the model, how to fine-tune the model. Data scientists will focus on the building the model. Okay, but sometimes too bad, some of the companies they don't have budget, so they expect you to do everything from beginning to the end. And lastly, I'll tell you too, machine learning is an iterative process. It is continuously improving the model. So it's never one-time job. Okay. So to actually start any machine learning, if you're lucky to join a company, if the company has never taken any steps starting machine learning, always start small. Okay. Start small to achieve certain results and measure small successes. Why? Because a lot of times most companies do not have experience deploying or applying machine learning models. So don't work in a company and say, oh, tomorrow I want to do AI, I will found 1.4 million in the budget, and then I want to see results in 1 year time. This kind of company you better don't join because they do not know what they want and they do not know what they're jumping into. And it's very dangerous because they want to start big and they have no experience. Okay. Normally, people will start small. Start small project, kick off a pilot project, then can see, gain experience, then will go big. Usually, how long is the duration? It takes about 2 to 3 years to see a good result. Okay, it's never 6 months or 1 year thing. It's very difficult. So you look at the machine learning life cycle itself, you already know that first you need to gather data. A lot of times the data is not there. Prepare the data, process the data, analyze the data, train, test, then on deploy. And go back to the same cycle. Okay. Okay, so that's the end. I hope that I'll cover the overview of the whole machine learning. I will just click this link to open up the Kaggle notebook. Okay, I don't think I have time to go through everything, so it's just a demo. So what you need to do, click the link, and then you can save and edit. That means you have a copy of the notebook in your Kaggle account. If you ask me what's Kaggle account, something wrong, okay. So you edit, okay, you see the whole notebook here. Okay. So the whole notebook basically will tell you, I will first start with data exploratory EDA. So data exploratory is very important because I want to get a feel of the data. That means I want to see what's the column or variable that I have, what's the range of my data, what's my label data. Okay, that's very important. Okay, so once you copy and edit, okay, you can actually go and run it. For example, let me run now. So we have a Kaggle notebook. Okay, you can just click a site here to run or control enter. So you run, you create a session in the Jupyter notebook. Okay, so the first thing is I want to import all the libraries. Okay, if you don't want to run the Kaggle notebook, if you go to my GitHub, you can see the same thing by using Google Colab. So if you click on that, you can actually run the whole thing in Google Colab for this. Run the whole thing in Google Colab. Because we are Kaggle, then we just use Kaggle. Okay, then once I import all the libraries, I will read the data. So this data is a biomechanical data. That means, okay, you can actually see this data related to the pelvis data, your backbone and your the data of your pelvis area. Okay, so I want to see the first 5 rows. I use the head. I can see a row, so you can see now What is my data? I have a supervised learning data. So I have a 1 column, 2 column, 3 column, 5 column, 6 column, 7 column. I have 7 variables and I have a label, the class. Okay, so whether abnormal or normal. So I can use the .info. .info will give me the range of my data. So you can see the data is float. Okay, then I have 7 columns. I have 310 entries. Okay, 310 entries. That means 310 rows. Okay, then I can see the rest is a data frame. Okay, so you can see the length is 310 rows. Then all the variables are float. Then I have my class, which is my label, target variable, which is a string. Then I can use the describe. Describe will give me the statistical range of data, the count, the mean, the standard deviation, the quartile 1, quartile 2, quartile 3, and the max value, mean max value. Okay. Then normally what I'll do a scatter plot. Okay. So I'll do a plot. Okay. So this scatter plot will show me what? Okay. So what this scatter plot will show me? Okay, you see, if the plot all there is, you can see the plot, they're all close together. Means what? There's a relationship. There's a relationship. That means one variable is this variable and this variable, there's a relationship. Okay. If I want to do regression, I will see, oh, this one I can plot straight lines. That means I can actually do regression for these two variables. Okay. So when I look at data, the EDA, the exploratory data analysis, first thing is I just do a simple plot. Then from there I will know whether I can do regression. If the data all scattered, I can even draw a line. That means regression is all of the solutions. Okay. So this is normally what we do. Just eyeball the data and see whether is there any correlation or not, what you call. Okay, if there's correlation, that means I can do a regression. Okay. So you can see, for example, here, you cannot do a straight line. There's no regression. Okay. For example, this one, there's some correlation. Okay. You just eyeball the data to see whether correlation or not. Okay. So this is what we call EDA. Okay. After that, what you do? Okay. You can plot the data to class. Okay. So you can see the data. There's about 100 count, which is normal, 210 count, which is abnormal. Okay. Why I want to do this plot here? Because I want to see how balanced is the data set. Okay. Of course, this is okay lah, not too bad lah, 50%. Okay. If I have the normal very low, the abnormal 90%, and the normal is 10%, then we call this imbalanced data set. Okay. So what's the danger of imbalanced data set? What's the danger? So I have a data which is imbalanced. Let's say 90% is abnormal, 10% is normal. Okay. What do you think is the problem? Anybody can guess? Yes. The model will bias, not bias. The model will always predict 90% abnormal. Why? Because your data 90% is abnormal. So no matter what I do, if I simply predict abnormal, I'll be correct. 90% correct. Okay. Then your model always will predict abnormal, because no matter what I do, 90% I will get correct. Okay. So you have a problem. Okay. So one of the biggest problems for data scientists to solve is, what do I do when I embed data set? Okay. You can go and Google. There are many steps out there to actually train the model in a more balanced data set. Okay. Okay. So in machine learning, Let's say now I want to do KNN. Okay, so after I have done the EDA, so in machine learning, the first step is select the model that you want to use. So how do you select? You import the model. After you import the model, you intercept the model and tell the model what is the number of K that you want to use. For example, the number K here, you say 3. Then your model will go and find 3 neighbors and determine whether class A or B, abnormal or normal. Okay? Then from there, okay, you feed the model, you train the model, and then you predict the model. Okay? So what do you think is the problem here? You feed the data, the whole data, and then you use the same data to predict. What do you think is the problem? You show all the picture of the apple, then you use back the same picture of apple and ask the machine, what is this picture? How do you think is the model going to give you? What kind of accuracy? 100%, then they're stupid. Okay, you show all the answer to the machine, and then you take back the same question and ask what's the answer. So this is wrong. So what you need to do? You need to split the data. Use 80% of data to train, then take a 20% never train one, okay, and ask to predict. Okay. Then you compare the results. Okay. There's no marker pen in the classroom. Okay, never mind. I will show this diagram here. Oh, sorry. I think I have the diagram here. So this is your data set, isn't it? You split to training testing. You train the model. Then this testing here, what you do? You type the Y, and ask the machine to predict the Y. Okay? You hide the Y and ask the machine to predict the Y. Then the predicted Y, you compare with the actual Y. Because you have the Y that's not there. You compare. Then you know how good your machine predicts for unseen data. If your machine, of course, your machine will, after you fine-tune your model, your machine will work very well in the training, maybe high accuracy. When your machine actually sucks in the testing, that means what? What's the term before it? The machine works very well in the training, sucks in the testing, over 50. Okay. So what you want to do is your machine achieve reasonable good result and also achieve reasonable good result testing. This is what we call generalized model. So you want a model to work very well, both training and testing.
What's the difference between validation and testing data?
There's no difference. Sometimes when you have extra data, you can speak to another 10% for validation, another 10% for testing. But sometimes you don't have a lot of data and you just speak to training testing. Okay, just extra testing. Okay, so this is normally what people do. Let's say you are in a company and then there's one software machine learning company can tell you, my model very good. Okay, my model accuracy 90%. Okay, how do I prove it? So the company will come to you and say, okay, never mind. So your company will come to you and then say, I have this machine learning model work very well. Okay, so you give the data, you give the training data to the model to train. Then you ask the company to test on the validation data. Lastly, the testing data you'll be keeping in your safe for very long. Then you test it. Then you know whether how good is the model. Okay, so that's if you have extra data. But normally what we do is we split 80% for training, 20% for testing. Okay, so this is where we use the train test split. So you split the data. So for this case here, we say 0.3. That means you use 70% for training, 30% for testing. Okay. Then you feed again, then you predict. Okay. So you can see here, with K equal to 3, the accuracy is what? 0.3. So the accuracy is 0.3. Okay, those are getting data error, is it? Go and download the data from here. If you look at the side here, there's a data here. Click on the data here. Click on this data, then you can download the data. Okay. The data is here, beside here. Okay, so you can see now when I speak to 70% training, 30% testing, when k equals to 3, the accuracy is 0.3. Okay. Sorry, I think I didn't test it. Let me test it. I didn't put it here. Sorry, the accuracy is 86%. Okay. So what you can do now, you can actually change that. You can actually train the k value and see whether changing the k value can improve the accuracy. So this is what we call hyperparameter tuning. Okay, so you can try to change the value of k and play around with different k values and then see the accuracy. So you can plot a graph like this. From k equal to 2 all the way to k equal to 24, what the accuracy will be. So you will see that the training accuracy will drop as we increase more k. Okay, we increase more k. So you find out what's the best accuracy. So you see the best accuracy around here, and you does not drop. You do not want the testing accuracy more than the training accuracy. So you can see here, this is the best, the testing and the training about here. So around here, 80, k equal to 80 is the best. Okay, so you can actually do this kind of evaluation to find the best model. Okay, next we can do regression. So regression, like I say, is for continuous data. So normally when we do regression, we just plot it. So like I said, I want to actually see whether the correlation of my data. So from here, I can see that the correlation between these two variables, pelvic and sacral, because I can draw a straight line. If the data point are very scattered, I cannot even draw a straight line. There's no point doing regression. Okay. Then, like I said, same. I import the model called linear regression. I instantiate the model. Okay. Then I will fit the model. Then I will predict the model. Okay. So you can check the result. So now this is the model that is built by the linear regression, and this is the line that is built by the linear regression model. Okay. Then how do you measure how good is the model? For regression, we use something what we call R-squared. The R-squared score is 64%, 0.64. The value is from 0 to 1. 64 means what? 0.64 means what? 0.64 means my model able to explain the variation of 64% of the model. If it is near to 1 means very good. Very, very good. The line cross all the dots. Here, the model can explain about 60% of the model. Okay. The higher the R-squared, the better. Okay. Next, okay, we have classification. One of the classification model that we have is called random forest. Random forest is one example of the decision tree. So for classification, how do we measure how good is our model? Okay. The classification, we measure a model by using what they call confusion metric. Okay. So confusion metrics, okay, when we do prediction, we want to know, okay, whether it's true positive, true negative, or false positive, true negative. What is all this? Okay. This is the actual value. This is the predicted value. Okay. So let's say dengue. Let's say dengue. Got dengue, actually the data, this person got dengue, no dengue. Okay. Then the model predicted to be negative. No dengue, got dengue. Okay. If I can understand, let's say I'm giving a dengue, you have a model to predict whether the person has dengue or no dengue. And this is the actual value, actual label. and this is the predicted label. Okay, the actual data say the person got dengue, or the actual data say that person got no dengue. But the predicted data say the person got no dengue or got dengue. Okay, so if the person got dengue and the model predicted got dengue, that is called true positive. That's called true positive. If the person got no dengue and the model predicted got dengue, that is called false positive. Okay, if the model got dengue and the person got dengue and the model predicted no dengue, that is called false negative. If the person got no dengue and the person model predicted no dengue, that's called true negative. Okay, let me ask you. If the person got dengue, the model predicted no dengue is more dangerous than, or the person got no dengue, the model predicted got dengue. Which is more dangerous? Which is more dangerous? No dengue, the model predicted got dengue. Or the person got dengue, the model predicted no dengue. Which is more dangerous? Which one? False positive dangerous or false negative dangerous? This no problem that means correct The model got dengue, predict got dengue, or no dengue, predict no dengue. So this one no problem. So which is more dangerous? The person got no dengue but predicted got dengue, or the person got dengue but predicted no dengue? Which one more dangerous? Why false positive? Huh?
False negative.
Okay, you go doctor, you got dengue, no? The doctor says no dengue, go home, take Panadol. Or you got no dengue, but the doctor says you got dengue, go hospital. Which is more dangerous? Huh? The first one, why? Because you got dengue, you are positive. So you got dengue, but the model predicted you have no dengue. So you have dengue, but your model predicted no dengue. So doctor said go home, take the Panadol. But you have no dengue, but the model said you got dengue, go hospital. So which one is more dangerous? Go home, is it? Because you got dengue, go back take Panadol. But if you have no dengue, go hospital, never mind, you go hospital already, take medicine, but then no dengue, one day you get discharged. But you got dengue, the doctor asks you go home. That's very dangerous. There's a lot of time, people got dengue, you go clinic, the doctor says just normal fever, go back and take Panadol. And then after that, 3 days later, the person got high fever, then go to hospital too late. Blood cell count very low. Okay, so when you do classification, knowing the false positive and negative, the ratio is very important. Not just determine whether correct or wrong, also determine whether false positive or false negative. So this ratio is very important. Okay? Just like fire alarm, ring. People all go down. Then say, oh, false alarm or no fire. Then you just wasted time. But for fire ring, people say no fire. See, never happen. Fire down, come, got real fire, then you'll die. Okay. So determine the false positive and false negative, the ratio is very important. Okay. So when you do classification, the model evaluation not just determine whether correct or wrong, but determine how wrong is the false positive or how wrong is the false negative. That determines how good is the model. Okay. So you can actually do this confusion matrix using the library called confusion matrix. Okay. So by combining this confusion matrix, you can what we call calculate the F1 score. Okay. So the F1 score will evaluate how much of false positive correct and how much false negative correct, and take into consideration all these 4 quadrants. The higher the F1 score, the better the model. Okay. So for example, if you average out the F1 score, this is 84%. Okay. So this is the model for this random forest. Okay. Of course, you can actually visualize it like this. You can see that. Okay. So model evaluation is very important because from the model, okay, then you can see how good is your, especially this confusion metric, okay, to measure to use this, especially when you have imbalanced data. Okay, so you can actually look at this false positive, false negative. Okay, so I hope you can actually go back and try this code and run it and try to understand here. Of course, everything also will be available in the 𝐏𝐨𝐨 𝐊𝐵. Okay, and then if you go to my GitHub, okay, there's extra exercise. Okay, if you have time, you can try out the panda exercise. So the panda exercise is good if you need something to test your knowledge so far. You can try the panda exercise. So the panda exercise is, for example, how to create this, you can try it out. It's quite good actually. All data is already available. Just click and run and then get the result. Okay. I'll leave this exercise to you to try. If you need guidance, whatever, join the Discord channel. The Discord channel will a lot of people, the tutor will help you to solve the problem. Okay. Now I think I will come to the end. I will try to answer all the questions here. Okay, first question. Okay. Another finally, 4 minutes finally. Must find you. Okay. Yeah, okay. COVID. Are you sure without certification can I get a job? If I say can, then what can I get? If I say cannot, do you believe me? I cannot guarantee that. Depend on the company want to hire you or not. Okay. But data science, there's no certification data science. There's no actual or certified data scientist. There's no certified AI scientist. There's only certification for TensorFlow, certification for AWS machine learning, but there's no certified data scientist. There's no certified ML engineer. Okay, but if I will be hiring a job, I don't care whether you're certification or not. You just show me your portfolio. You can say, oh, I have a lot of things in my GitHub. I have this project I have done. You show me. Okay. I don't look at certification. It doesn't mean you certify or you have a CGPA 4.0, you get a job. Okay. It's about how good is your how initiative that you have, what initiative that you have taken your time, and how much interest that you have, and show your portfolio. Then that will convince me. Okay. So that's one thing. Explain more reinforcement learning. What else to explain more? To learn more, go to you can actually go to AI, OpenAI. You can actually learn about reinforcement learning. Go to OpenAI. Sorry, OpenAI learn reinforcement learning. There's a course in the OpenAI, I think. So you can just go learn the open course there. How do I find that our model is good? So like I said, in model evaluation, there's a lot of criteria you can actually evaluate your model. There's AUC value, there's a lot of other value that you can actually do evaluation of the model. Okay. When you learn machine learning, definitely you need to learn about model evaluation. Then you learn how good is the model. Okay. There's a lot of parameters that you can actually control. there are a lot of model evaluation, this metrics that you can actually value. Sir, in your opinion, do we prefer train using real data set than test with open data set from paper or vice versa? How to test something from different data set? You must actually test something from the same data set. It's because you split the data set to testing and training. How much demand are there for machine learning job currently? Oh, the question keep on jumping on. How much demand are there for machine learning job currently? The demand is there, definitely, and the salary is quite good also, especially if you can prove that you have the job skill set required. How best to determine the k-nearest value? There's something what we call this elbow. There's something what we call elbow plot. You can actually determine by changing the value of k, then you can compare the result. So sorry, I'm beginner. How do we know which model to use? Trial different models. There's no one set model. Try the model that you know, and then fine-tune the model. If you think there's other model better, then try the model. How do I spot a data leak in ML? Data leak ML you can spot if you model, like I said, overfitting. Because once the model overfitting, one of the reasons can be data leakage. What is the difference between 𝐾𝐨 and Google Colab? Spelling. Google Colab is notebook. 𝐾𝐨 is one. Is 𝐾𝐨 okay? What is 𝐾𝐨 actually? If people don't know what 𝐾𝐨, okay. 𝐾𝐨 used to host a lot of competition. Okay, if you are a good data scientist, okay, if you're a good data scientist, you want to earn some big money. You can, for example, here they're giving you 100,000 USD. Okay, so there are people who call them 𝐾𝐨 Grandmaster. Okay, 𝐾𝐨 Grandmaster. So what they do? They achieve a certain status where they achieve, where they actually win or won a few competitions. Okay, then they win all this money. There are some people who are just forming a team like 3 or 4 persons. Their job is just participate in 𝐾𝐨 and split the money. Okay, so if you are so the 𝐾𝐨 is host all this competition by all these companies where they expect people, they give reward money, they expect people to solve their machine learning problem in the company. So they open up the data to the whole world. People come and try to beat the competition. So for example, you got this competition here. Okay, you can see the leaderboard. Okay, so this leaderboard, this guy young for you. Okay, he hit about 0.801% accuracy. And he already submitted 231 times. And this person, this competition got 12 days to go. And with this person in 12 days to go and he's still number 1, he will get the 100,000 USD. Okay, and you see this person, just go to this person. You can see this person in China. He is a grandmaster. Okay, he's a 𝐾𝐨 Grandmaster. Okay, so one of the ways to show that how good you are in data science, you show me that you are 𝐾𝐨 Grandmaster. I'm sure I'll hire you. Just show me that you are 𝐾𝐨 Grandmaster. I'll show I'll hire you. Okay, so you see this person. Okay, he's based in Chengdu, China. He's a 𝐾𝐨 Grandmaster. 𝐾𝐨 Grandmaster means what? He has won a few competitions in 𝐾𝐨. Okay, that means his skill set is very good. Okay. Okay, coming back to the question, what's 𝐾𝐨? 𝐾𝐨 is a website where it hosts all this competition by all the data from the company where they give you reward money. Okay, there's only one 𝐾𝐨 Grandmaster in Malaysia, and he won one of the competitions. You can just Google him, but he's not working in Malaysia anymore. Too bad, he's working in Singapore. Let me see. The person is called, I forgot his name. He was actually interviewed by 𝐾𝐨. Kylie is the person. He's from Penang actually. Okay, so if you want to read about him, if you inspired to be 𝐾𝐽 Grandmaster, go read about him. So he actually won the competition where he used that time he used a few GPU to solve the problem. Okay. This article no longer available, but you can go and Google this person, 𝐾𝐽 Grandmaster 𝐿𝐽. Okay, so coming back to 𝐾𝐽. So with 𝐾𝐽, you can see there's a lot of competition. So what you can do is sometimes people share their notebook there. Of course, those competitions still going on, they will share the notebook. Okay, those ended one, some they will share notebook and some they will do a lot of discussion there also. Okay, so what I will do is I will use 𝐾𝐽, I look at all discussion, I look at how they solve the problem, I look at how their notebook, I learn from them. You can also share your notebook in the 𝐾𝐽 also, like I shared the notebook just now. Okay, so 𝐾𝐽 already been bought by Google. So Google owns 𝐾𝐽 now. Okay. Oh, with that in mind, I also forgot to tell you that I also created the 𝐾𝐽 competition for 𝐸𝐴. Okay. So if you go to the Malaysia ML study.com, you can see the 𝐾𝐽 competition there. Okay. The link to join the competition is in the Discord channel. Okay. It's only open to you guys, not open to the public. So hopefully after these 4 weeks, after you learn all the theory of machine learning, I hope that you can apply in this 𝐾𝐽 competition and show that how good is your knowledge. But of course, I cannot give you the title Grandmaster. Okay, can you recommend some company which offer interns? I cannot recommend. There's so many companies out there. Just go to LinkedIn, you can find people who are actually looking for interns or data science job. In the real world, how will you control prediction time? Okay. Okay, prediction time depends on a lot of factors. Depends on the architecture, depends on the data model, depends how you deploy your model. There's many things you need to know. That's why in the real world deployment model now, people need to know about cloud services. Okay, a lot of cloud services are needed knowledge to know. For example, now people deploy in Azure, or people deploy AWS. AWS is something we call SageMaker. In Google Cloud, we have something we call Vertex AI. In Azure, we have Azure ML. So all these tools help you to deploy and also help you to manage your model. How do we use review data booking.com? Is web querying related to machine learning? Yes, if you want to get your data, then you need to crawl your data. Most of these booking.com, iProperty.com, Shopee.com, whatever, they will block people to crawl the data. Okay, because again, data is something valuable to them, and they wouldn't want people to scrap the data. How do I start building a portfolio? Start a GitHub page, start a project, and also maybe show your participate in 𝐾𝐽, lot of discussion, share your notebook. Those are things you can do. Data drift, concept drift. There's a what we call ML ops. There's a what we call model monitoring that you can actually read about that. What's my portfolio? I have no time to do portfolio. I'm already working in real life already. My portfolio is in my company. Can we follow your footsteps? Okay, again, I will give the same advice. Learning is never ending. Okay, like now I'm still learning also. Okay, but your learning and my learning are a bit different. Because your learning is to build your portfolio and to build your career. Okay, so you must plan what I want to learn, how do I learn to market myself, a portfolio. Okay, how do I market myself? Again, a lot of people say I do not like to blow my own trumpet. I'm a very shy person. If you shy, if you don't showcase what you have done or what you have learned, how do people know? You go interview, people say, what do you know? I'm very shy, I cannot explain to you. How will you get a job? Okay, you must showcase. Okay, showcase things that tangible people can see. Become 𝐾𝐽 notebook, participate in 𝐾𝐽, become a 𝐾𝐽 Grandmaster. Those are things you can do. Okay. In Kaggle, we can't download the set. Okay, if you cannot download the data set, you can go to my GitHub. There's a data there. You can download the data there also, which is this column 2 CSV. Again, go GitHub. Okay. What else? Reason lower accuracy during feature selection. Okay. Then you need to do another hyperparameter tuning and see what else you can actually improve your model. Do we train test speed before encode categorical variable or standard? You speed first, then only you do this normalization. Speed first. Okay. Non-IT consider variable domain knowledge. Yes, because even you work in the machine learning field, machine learning can be applied in many domains. Can be applied in finance, can be applied in banking. Okay, so certain non-IT domain knowledge is also relevant. How to vary performance unsupervised learning? Okay, so there is some model out there that can actually do the evaluation. Okay, you can actually read about it. Is data science a glorified name for statistics? No. If you just know statistics, can you do programming? If you cannot do programming, then how you want to do data science? Which is the preferable Python IDE? I use PyCharm if you want to use PyCharm. But if you're data science, normally what we do, we use the Python notebook, and you can just use the Python. Can you put your mouse?
I'll take a few more questions.
Yeah, but that's 3 more questions. Do reinforcement learning use together supervised learning? Depends on the situation whether you need reinforcement learning. Joint company for machine learning experience or joint top company? Very funny you asked about your career. Joint company that you think can give you better learning experience? Okay, last question. What's the difference between job scope for data analyst and data scientist? So data analyst usually as a word do analysis. So usually, if I have no experience as a data scientist, I will apply for data analyst first. Plus data analyst, I will probably do some EDA. I do not need to build any model, but slowly I learn from the data scientist. So usually data analyst is one step lower compared to data scientist. Okay. So data analyst will be your what would I say entry to your data science. If you want to be a data scientist, if you have no experience, then maybe you can apply to be data analyst first. Then that will be a good step for you. Okay, I think I will stop here. If other questions you got time, you ask in the Discord channel, I'll try to answer them. Thank you very much.
Okay, thank you, Dr. Fu. I think that was a pretty informative talk. I think all of us here learned a thing or two from that. All right, so now we're going to a quick photo session. Because there's online and the physical people, so we're split 2 ways. The online one will be conducted by one of our committees, and the physical, Rachel, you'll be taking a good photo, right? Yeah. So Rachel will be taking a good photo for us. All right.
Okay, so for the online people, can you all open your camera if you are like okay to open? Yeah, thank you so much. Okay, I look a bit tired. But hopefully, yeah, I see all of you look so good. Come on. It's a Saturday morning. Yeah, thank you, Dr. Pu, so much. It's okay, no worries, Leon. If you are convenient, you can just open your camera. Okay, I see more and more camera opening. And we would like to apologize if like the mic is a bit muffled for like Dr. Pooh, but we'll try to like improve for the next 3 sessions. And yeah, we'll try our best like to make it more clearer. Hopefully the content is good for all of you. Okay, I'll give like maybe 10 more seconds for y'all to open your camera. Yeah, no worries, Daniel. Yeah, just try your best to open if you it's convenient. You are convenient. But if for the physical one, I think y'all can unpin me, or else it will look so weird. My face is so big on the screen. Okay, now let me pin. Okay, it's okay now, mine. Yeah, thank you so much, Dr. Pooh. No worries. Thank you so much. Later for the feedback form, we'll share a slide and the link in the chat too. Okay, so I'll take the photo now. So for the online one, I will take 2 because there are 2 pages. So Termin, do you want to open your camera because you are on my first page? And you are the only one opening. Okay, but it's okay. Okay, I'll take one now. Okay, yeah. 1, 2, 3. Let me save it first. Okay, one more for the first page. 1, 2, 3. Okay, now for the second page. Hold on, yeah. Okay, for the second page. 1, 2, 3. One more for the second page. 1, 2, 3. Okay, thank you so much. Okay, let me share the screen for the feedback form first. Okay, maybe in the meantime, when the physical people are still taking the photo, for the online participants, you all can scan the QR code on the screen, and my team will send the chat for the link to the feedback form. So really like appreciate all of the feedback from all of you like throughout the event, like from all the DMs and from Discord. So we'll definitely try to improve for the next 3 sessions, because I'm sure some of you also mentioned like the voice was not like clear. Most probably was because of the double mask. So we'll still try our best like to make it clearer for the next few sessions. So we'll be having physical sessions for the next few sessions too. So if you all prefer, I'm so sorry. So if you all prefer to like join physically, there's like limited spaces, so do register as soon as possible when the link is out.
Thank you for attending. Thank you.
MC is back.
Everyone think we feedback form. So for those that are still here, you can fill the feedback form. So you know how to improve on the next event. And also the next slide.
There's feedback box. There's a feedback form in front. Scan.
Never mind, I'll send the feedback form later in the Discord so you guys can fill it in. And also here are the resources, like you can join the Discord if you haven't yet, and also the GitHub and the websites are here. Okay, yeah, that should be it.